Lab 25, Example 1, Part 2. We have the same system of equations. We're going to move on to Part D. So Part D, it says replacing the x column with the constants column of the coefficient matrix gives us the matrix, this matrix right here, 13, 5, 5, 2. Find the determinant dx of this matrix and divide by the determinant of the coefficient matrix we found in Part A. So essentially what this first part is saying, how we got to this matrix, was, if you remember from the previous part, our coefficient matrix was the matrix that we got from just taking the coefficients of each of our variables. So this was the coefficient matrix. We had 6, 2 and 5, 2. And this was the x column and this was the y column. And what we've essentially done is we've taken this and we've replaced our x column and we put in our constants column. So this would be the constants column right here, 13, 5. And so we've changed this to 13, 5 and 5, 2. So this is how we got to this matrix. And it wants us to find the determinant dx, that's just how they're determining it, of this matrix, and divide by the determinant of the coefficient matrix we found in Part A. So first we need to find the determinant of this matrix right here. If you remember from the previous section, it's going to be, if we have a matrix that's a square right here, 2 by 2, we have A, B, C, D. Our determinant, I should not have written that way, our determinant is going to be A times D minus C times B. So our determinant x of this matrix is going to be 13 times 2 subtract 5 times 5. And this is equal to 26 minus 25. So our determinant, our dx, is going to give us 1. Now we're not finished yet. It asks to divide this determinant, this 1, this dx, by the determinant of the coefficient matrix we found in Part A. So in Part A, we found that the determinant of our coefficient matrix was 2. So if we have dx divided by d, this is 1 over 2, or 1/2. So that's Part D. Moving on to Part E. As replacing the y column with the constants column of the coefficients matrix gives us this matrix right here, 6, 2, 13, 5. Find the determinant dy of this matrix and divide by the determinant of the coefficient matrix we found in Part A. So this is essentially the same thing, except instead of replacing the x column, we replaced the y column with our constant matrix. So now we have this, this matrix that we need to find our determinant dy of. So just like before, we're going to find the determinant of this. This determinant is going to be 6 times 5, subtract 13 times 2. This is 30 minus 26, which is 4. So to find dy, divide by d. Again, our determinant d is still just 2 from our coefficient matrix in Part A. This is 4 over 2, which is 2. So that's Part E. We're going to move on to Part F. Part F says to compare the answers in Part D and E. What do you notice? So in Part D, we found that dx over d is 1/2. So dx over d equals 1/2. And in Part E, we found that dy over d is equal to 2. So dy over d is equal to 2. And we're going to look at this, and we're going to go back to Part C and notice that it actually, in Part C, we found that the solution to the system was x equals 1/2 and y is equal to 2. And if we compare these two things, we notice that dx over d is equal to 1/2, which is the same thing as the solution for the x variable, x equals 1/2, and dy over d is equal to 2, which is the same thing that we got for the solution for our variable y, which is equal to 2. So essentially what we've noticed is that it gives us our solution. So this gives us the solution to the system of equations, which was x equals 1/2 and y is equal to 2. So if you had more variables, you could do more things with it. You could find the solutions just by using the determinants and this kind of pattern. And this right here is actually called Cramer's rule.